Well, here we go. Awesome. Angle. Notes. Part 3 now. So we're going to the third part of this. And in this part, what we want to do is extend on this idea that the angles inside of shapes add up to certain amounts all the time. So one thing we already know is that when we have a triangle, the three angles in a triangle add to 180 degrees. And we can use that to do any number of any shape that has any number of sides we want. And I'll do them one at a time, and then we'll summarize the results. So for instance, let's say I had some kind of quadrilateral like this. And we want to know what the sum of the angles in there was. And it's a nice, simple trick that allows us to come up with that is we just take that quadrilateral and draw an imaginary line across there. And what we know is the angles in this triangle have to add to 180. And the angles in this triangle have to add to 180. And so the sum of the angles of this shape, the quadrilateral, equals 2 times 180, which is 360. So now we got four-sided figures. And we can do the same thing for any number of sides. So if we want to go to a five-sided figure, any five-sided figure we want, we just have to divide that into triangles. Now, the only thing you have to be careful of when you divide this thing into triangles, it's the only warning in all this, is you can't cross these imaginary lines you're drawing to divide up the angles. You can't have them cross each other. So you got to sort of divide from one vertex like this. If the lines cross each other, you're creating new angles. And so with a five-sided figure, you get 180 in this triangle, 180 in this triangle, and 180 in this triangle. So now, sum of the angles. I'm just going to add an extra word this time. Sum of interior angles is 180 degrees times 3. So it's 540 degrees. I'll do one more shape, and then I want to summarize the result. So that's a five-sided figure. If I made it something with a six-sided figure, I'm not trying to make it regular here. 1, 2, 3, 4, 5. 6 sides. And again, you have to divide from one vertex so you don't get extra angles. And so now there's 1, 2, 3, 4 triangles, and the sum of the interior angles is now 180 times 4, which is 720 degrees. Well, let's just summarize what we've come up with here. If I put n for number of sides, and then I put how many triangles we got inside. And then I make another column, sum of interior angles. For a three-sided figure, of course, we only have one triangle, and the sum of the interior angles is 180. For a four-sided figure, we got two interior triangles, and the sum of the angles was 360. Because what we did is we took 180 degrees, we multiplied it by 2. For a five-sided figure, we got three interior triangles, and so then it was 180 times 3, it's 540. And the last one we did was 6 sides. There was 4 interior triangles, and so we went 180 times 4, which is 720 degrees. So what I want to do, without actually drawing the next shape, is I want to say, well, what if there was 7 sides? How many interior triangles? And I hope you see the pattern there. There was always 2 less triangles than there was sides. So here we get 5. And now I want to extend that to any number of sides. We can do any number of sides without having to draw it. Is say, well, what if I went to like 99 sides? How many interior triangles? That'd be tough to draw. But if you did draw it, what you'd find is 97 interior triangles, and you'd go 180 degrees times 97. Well, that's pretty crazy. Let's just type it in to get the answer. 180 times 97 is 17,460 degrees. So are we going to do 99-sided figures? No, but just to get the idea that we can do any number we want. In fact, we can make a formula. We can say for any shape with n sides, there will be n minus 2 triangles, and if we want the sum of the interior angles, we can just take 180 and multiply it by that n minus 2. So now we can do any number of sides with just using this formula here. So that formula is very worth copying down on a study sheet and memorizing, because that we're going to use. 2 quick examples, and then we're done for the day. Here's the first example. I'm going to go a step farther with this. Find each angle in a regular octagon. Okay. Octagon has 8 sides, and they want to know each angle this time. Well, okay, if it's an octagon, and I'm not going to try and draw it perfect, but they want a regular octagon, and what that regular means is all sides equal, all angles equal. So when they say regular, they mean everything in it. A perfect octagon, like you see in a stop sign. So I'm going to try and draw one that's, well, mine won't be perfect, but it'll give you the idea. So there we go, regular octagon. And so they want each angle, but first, before I go after each angle, I'm going to find the sum of the interior angles. So here's the formula, written out a little more formally. We take 180 and we multiply that by n minus 2. So in this case, I want the sum of the angles in an 8-sided figure is 180 times 8 minus 2. So the sum of these angles is 180 times 6. I get 1,080 degrees. Those angles all add up to 1,080 degrees. Now, the only thing is, though, each of those angles is the same because it's a regular octagon. So 8 times x has got to be 1080, and now I can get each individual angle, which is 1,080 divided by 8. And I think you get 135 degrees when you type that into your calculator. So you just take a second in those situations and divide that out when the numbers get a little too big for you there. So you can check that. If you just add those all up, you get 135 degrees. If you draw a regular octagon, each angle will be 135 degrees. So that went a lot farther than the table did, and that's the kind of question you might have to deal with in these type of situations, is being able to use that sum of the angles formula to get the sum first and then break it down. My last example for angles. We've seen something like this before, and I'm going to draw a quadrilateral, and I'm going to put some different angles in here. I'm going to call this 2x minus 10 degrees, and I'm going to call this 3x, and I'm going to call this 85 degrees. And then the last angle's I got a little right angle symbol there, so it's a 90. And the question will be solve for x. Now, we've seen this before in the case of triangles. The only difference here in the 4-sided figure is we need to know the sum of the angles in a 4-sided figure, and you can use the formula, or you can just know from there that, hey, look, the sum of the angles in a 4-sided figure is 360. So we know that these have to add to 360. So I got to go, okay, 2x minus 10 plus the 3x, plus the 85, plus the 90, that's all got to come out to 360 degrees this time. So I get 5x, let's see, 90 plus 85 minus 10, I think I get 165. Then I got to subtract it. And I'll use my calculator on that one just to be sure. And I get 195. And then just divide by 5 to get the x value. I get 39 degrees will be my x value. So that question should seem kind of familiar. I'm just using a new formula to get the sum of the angles in a different shape there. Okay, so some extra homework today because now we can tie all those things together. You can get questions that have triangles. You can get ones that have parallel lines. You can get things that add to 180 or 90, but now you can get different shapes in there as well. So there'll be a lot more to do there. So really take your time and move through those so that you can handle all the different situations that come out there. Besides that, that's it. That's it, angles that we have to cover in grade 9. So work your way through that homework and have a great day.